Hey folks, Mr. Dell here. We are solving equations, but in this case, we have equations with x and y. So we're going to solve for one of those variables. So it's, yeah, I'll go through that process. So this is a problem that I'm taking from CPM course 3, and this is section 8.2.2. And this is problem number 8-70. So it says solve the equations below for the indicated variables. So if you notice, we have this equation here. I usually like to, again, put in my equation wall there so I know what my equal sign is, and what I do to one side of the equation, I need to do the other. And it says, here's my equation. 3 times the quantity 2x minus 1 plus 2y equals 5x. And wants me to solve this equation for y, right? So I'm going to cross that out. I know I'm needing to solve for y, but I don't want it to, I'm just trying to make sure that I can just see my equation only, right? So I'm solving for y. That means at the very end of this, I want my y all alone, right? So I'm going to go through the process of solving equations to isolate my y. And I'm going to have x's on this side. So I'm going to have an expression on this side that includes x and probably a constant as well. So let's see, let's go through the process. The first step of solving equations is making sure I clean up any parentheses here. I do any distributing property or combining like terms. So I'm going to clean up this side because this side is just 5x. So there's not much to clean up there. So let's multiply that through. So this is 6x minus 3. So that's taking that 3 and using the distributive property, multiplying 3 times 2x and 3 times 1. So it's 6x minus 3, no longer parentheses there, plus 2y is what I have. If I look, it's a term with an x, a constant term, and a y term. So there's no combining like terms. So now it's just a matter of eliminating what I don't want from this side, right? The whole goal is to isolate y. So that means I can get rid of this 6x by subtracting it opposite, right? Make that a 0. What I do to one side, I do to the other, okay? And then also I want to get rid of this minus 3. So I'm going to go ahead and add 3. So that makes that a 0. So I've got, now I have those two terms are eliminated from this side, and all that's left is just 2y. And on this side, now I can combine like terms and write my constant because there's no other constant. So these terms combine. So positive 5x, negative 6x makes it a negative 1x plus 3. So after eliminating from this side and doing the same over here, right? Subtract 6x, subtract 6x. Now I have my expression over here. Last step, it looks like, is what I've got to do is divide by the coefficient, right? Because I want just one y. So I got to divide by 2 to make that into a 1, right? When you divide by 2, you divide this side. You can either divide the entire side by 2, like all of the expression by 2, or what I tend to do is divide each individually by 2. Kind of helps show what the coefficient of the x is, because now I have a negative 1 over 2, so that becomes my new coefficient, negative 1/2 x plus, and then I could just leave that 3 over 2, or I can write 1.5 or 1.5, but I'll just leave it 3 over 2. So there is the equation here solved for y. Okay, there's the first one. Second one says, here's this equation now, and I need to solve for x. So I'm taking and solving for x. So here's my equation, put my equation equal wall, and I want to get x by itself. So interesting is we've got a 600x plus 200y equals 500x, right? So I have x's on both sides, but I only want them on one. And all that's over here is just an x term. So I'm going to end up trying to just get my x on this side, right? If I've got x on this side and x on this side, but all I have is just the x term on this side, I might as well eliminate it from here and just keep them all on this side, right? So I'm going to eliminate this 600x from this side. So I do the same thing over here, subtract 600x. So now I have 200y equals, that gives me a 500x, negative 600x makes it a negative 100x. And then last step for this one is divide by the coefficient. And we have that x becomes now 1, right? Negative 100 divided by negative 100 is 1x. And then 200 divided by negative 100 is negative 2. So that becomes a negative 2y. So now I have my x is equal to negative 2y. And you can always write it the other way. You can flip it around if you like to read it left to right. X is equal to negative 2y. Okay, there we go.